going to get us started here.
All right.
We're up to 34, which is actually great. So a lot of interest in your talk, John.
We'll see.
John, thanks for offering up a talk. Ellie, who you're just talking to, is the one who recommended you. John, for those of you who don't know him, grew up on the shoreline of Lake Superior in Duluth. He's joining us from Duluth right now. And John currently resides in his childhood home. He has BS degrees in physics and math from UMD, and then a PhD in geology and geophysics from University of Minnesota, Twin Cities. Were you a Chris Paola student, John? That's what I
Oh,
thought. I didn't know if that
absolutely.
was a postdoc or for your PhD. So um, John joined the faculty at UMD in the Earth and Environmental Sciences Department in 2001. And in addition to being on the faculty at UMD, John is also a consultant to industry, minerals and energy sectors for the last 14 years, first with Bar Engineering out of Duluth, and now with Mineral Logic, where John is a senior environmental scientist and mathematic modeler. And since 2022, John has also been a technical advisor to the city of Duluth with regard to the U.S. Army Corps Section 111 study for Minnesota Point, which is what we're going to hear about today. So take it away, John.
Great. Thanks, Tony.
Yep.
Let's see here. So I'm assuming everyone's been to Duluth at some point and is familiar with Minnesota Point. So let's get right down to things. Duluth, just for some background, like many coastal cities, Duluth has problems with how the residents play with coastal processes, and in particular, how shoreline erosion is a ever more pressing issue. So many of you are familiar with the Lake Walk. The Lake Walk was recently damaged in 2017, 2018 by some large storms on the lake. They caused north of $30 million in damage. City rebuilt that. And then in the process of rebuilding the Lake Walk, they armored the coastline, as is shown in that image that's hiding there, to the tune of probably now north of $25 million. And the design was to try to build that lake walk or protect it against more intense, more frequent storms. Another just recent example of coastal erosion in the news, Duluth Park Point, is the residents think it's washing away. And this is going to be the topic of my presentation mostly today. I'm also going to come back and talk a little bit about, if I have time, a little bit about the idea that there are more intense and more frequent storms on Lake Superior. So I don't use AI very much, but I did use it for this talk, and I Googled this quickly and found that, we're probably, as a community, we've probably sunk northwards of $50 million into coastal erosion mitigation in the last, let's say, 10 years. And for a community our size, that's a substantial chunk of change. So it kind of begs the question. Many people feel this is related to climate change, anthropogenic climate change, and increased intensity of storms, et cetera. I would propose to you, and I think you can see where this talk's going to go, that there's probably a far simpler answer at hand, and that's hopefully where we get to in the next 40 minutes. So real quick, just some background. What is Minnesota Point? Minnesota Point is just a coastal barrier. So what I did in this image here is I took Minnesota Point and I took a Google Earth image and rotated it a bit so that it looked a lot like the barrier in Galveston Bay. They're the same thing. Okay, it's a net depositional feature that separates an estuary from the open sea. You need two things to make a barrier, basically. You need sea level or lake level rise, and you need a supply of sand. So first chunk of my talk here, we're going to do a little bit of geology, okay, a little bit of glaciology and a little bit of meteorology. And then we'll dive into more detail about the ongoing what's called Section 111 study, which is trying to determine the culpability of the Corps of Engineers for coastal erosion on Minnesota Point. Okay. the point I try to make to people frequently over the last 5 years is that all of the coastal issues in the far western arm of Lake Superior, they all lie downstream, if you will, of climate change. And not anthropogenic climate change, but Milankovitch cycling. And basically the problems or the reality that we all live with is tied to a plate tectonic scale process associated with differential crustal rebound when the ice sheets decayed and disappeared. That differential uplift generates a long-term lake level rise in the far western end of the lake. So Duluth is basically drowning. That lake level rise fuels sustained bluff erosion, which supplies sediment to the near shore. Rivers supply some additional sediment to the near shore. That sediment moves on both shores to the southwest, where it feeds what we call Minnesota and Wisconsin points. I'm going to use the term Minnesota point to refer to the entire barrier, which includes a component in Wisconsin. So no offense to any Wisconsin neighbors on the call. The irony here, to some extent, is that the very process that allows for formation of Minnesota Point, and at least historically has fed it with sediment, is also trying to destroy it by drowning it. So there's a delicate balance that is required to keep Minnesota Point's nose above water, if you want to think of it that way. And as we'll see shortly, the presence of the Duluth Harbor messes that up. All right, so a little more geology. When in doubt, seems to be the rage these days, blame Canada for the problems. So right here we have last glacial maximum Laurentide ice sheet. Everyone on this call is familiar with this concept. The main point here is that that ice sheet supplied a significant stress to the lithosphere, and in response, the underlying asthenosphere moved out of the way. When we take the ice sheet off, the asthenosphere has to recover and flow back, if you will, into our area. And the easiest way to think of this is a Tempur-Pedic or a Serta memory foam sleeper with about a 30,000 year recovery time. So all of the Lake Superior Basin is undergoing a recovery from the last glaciation. That recovery manifests in the form of crustal rebound. And there's a gradient in crustal rebound, which is illustrated very nicely here in this most recent set of data from Kramer and Wysotsky, 2021. And the salient point here is that if you compare the uplift rate, which is actually a subsidence rate in Duluth, but it doesn't matter for the purposes of this talk, minus 1.75 millimeters per year, relative to the outlet of Lake Superior at the Sioux, which is 1.25 millimeters a year in the other direction. You difference those, you get about 3 millimeters a year. And that is a lake level rise relative to bedrock in the Duluth area. And Tony, you mentioned my working with Chris Paola as a sedimentologist and a basin guy, if you will. That's a fast rate of drowning. So any sediment transport system is going to have a hard time keeping up with that pace. The net effect is that, again, in Duluth, we're drowning on the northeast side of the lake. It's the opposite. The northeast side of the lake is experiencing a lake level fall. We're experiencing a lake level rise. Okay, this is a great idea. I would love to, lay claim to it, but I would be about 100 years too late. So we understand this well. And it is somewhat remarkable to me that it continues to take time to get this concept through to policymakers, et cetera, and the implications of this rise. You can see the effects of post-glacial rebound very dramatically right in the Duluth Harbor in simple elevation data. So I just grabbed these data from the NOAA station up listed on the top of the slide there, plotted them up. And this is 150 plus years of lake level in Duluth, measured with respect to a deep datum. And you can decompose that signal into basically three pieces. There's a long-term rise that's due to the aforementioned crustal rebound. There are some decadal scale fluctuations superimposed on there that are attributable to changes in basin hydrology, basically the water budget within the basin, for reasons that are not terribly well understood. And then, of course, the noise on the figure is those are just annual cycles of very predictable lake level fall in the late fall and winter, and then lake level rise in the spring. Just to highlight that area right there, last few years, is really what caused the damage that sits fresh in people's minds around Duluth. But if you look back over the last 150 years, you will see that there are many previous highs or high stands in lake level, and those cause problems as well. So the net effect of this long-term lake level rise in far western Lake Superior is widespread and sustained bluff erosion. It's most pronounced on the south shore of Lake Superior, just east of the city of Superior. If you've ever had a chance to spend time over there along the coastline, you will notice that there are pronounced 60-foot high bluffs where the glacial till is retreating at about 0.5 meters a year on average. That's been ongoing for about the last 1,200 years, and it will continue for several thousand years to come. It's a similar problem on the north shore. It's a little less dramatic because the veneer of glacial debris on top of bedrock on the north shore is thinner. So there are places along the north shore where bedrock, well, in general along the north shore, bedrock is exposed. So the upper left image is actually a photo of my backyard. The upper right is kind of up the shore a little bit, and you can see that there's, again, a veneer of glacial material on top of bedrock. It's all retreating. On the north shore, that rate of retreat is about an order of magnitude less than on the south shore, but it is still substantial. This is a shared reality. Duluth has been addressing this reality in large part by not retreating, but by a coastal armoring. And we can debate offline the merits of that approach. So bluff retreat gives us sediment supply to the near shore. It's probably the dominant source of sediment supply to the near shore. And of course, for this presentation, we are interested in the coarse grained or sandy component of that. We don't, with all due respect to mud people, we don't care about the mud. That delivery of sand from bluff erosion to the near shore is augmented by additional input of sand from small scale rivers around the western arm. And those two sources together then comprise a load of sand and gravel on the north shore that is going to be moved down to the southwest and ultimately form Minnesota Point. Of note here is the St. Louis and Nemadji rivers, which are relatively, they contain relatively high sediment fluxes, but they are unimportant with respect to forming Minnesota Point because of drowning. Formation of the estuary is trapping their coarse-grained load upstream. So they are actually not significant from the perspective of forming Minnesota Point. That sand supply that gets to the near shore is mobilized during large coastal storms. So any extratropical cyclone trajectory that we have affecting Duluth, be it an Alberta Clipper or a Colorado low, any of those trajectories gives us a period of east-northeast long fetch winds down the long axis of Lake Superior, which have the net effect of mobilizing sediment on both the north shore and the south shore. Okay. The most important of those are what are called Colorado lows or Texas hooks. Those are the most intense storms that we experience in the upper Midwest, and those move most of the sediment. I'm involved in some complex modeling work that suggests that about 90+% of the sediment movement occurs during just a couple percent of the storms. So it's a very nonlinear weighting as to when the light switches on for sediment transport. So, sorry about that. these storms, these extratropical cyclones, they are often, pilloried by locals because they are associated with quite a bit of coastal destruction. But I think it's important to note that they are not bad. They are just simply doing their job of acting as a conveyor belt to move sediment down the shore and put it somewhere. And without those storms, we wouldn't have Minnesota Point to begin with. So long story short here, we have in the western arm of Lake Superior, the coastlines are net erosional. Sediment is supplied to the near shore, moves to the southwest during storms. And very importantly, you have a zone of very intense convergence of North Shore sediment supply and South Shore sediment supply. And historically, that is what has created Minnesota Point. Which brings us to Duluth's dilemma. We can have ships and sand, but we can't have them simultaneously. So in the post-Civil War period, both the cities of Duluth and Superior built large-scale breakwaters to allow access of ships to the estuary, which is now the Duluth Harbor. And that turns out to be those breakwaters were emplaced in what is arguably the worst possible scenario for the long-term well-being of Minnesota Point with respect to sediment. You will hear me refer to these as the federal structures because they are controlled and maintained by the U.S. Army Corps of Engineers. So the dilemma involves two things: ships, which require entry to the harbor and breakwaters, and the economic significance of shipping in Duluth it's zero order. It's the one game in town, so to speak. The problem that comes about with the sand. So if you open up any introductory textbook, you will encounter something about longshore transport of sand in narrow rivers along the coastline. If you stick something in the way of those rivers of sand, you are going to trap that material on the updrift side, and on the downdrift side, the now free wave power is going to go to work and erode beach material. So you're going to get an accretionary fillet, it's the fancy term for it, on the upstream side of these, any feature, any obstruction, and you're going to get downstream erosion. And maybe not stunning upset, what we see, or what we have seen on Minnesota Point, is that immediately following construction of the breakwaters on both the Duluth entry and the Superior entry, that time was accompanied by, we started to see focused erosion on the downdrift side of the structures and deposition on the updrift sides. So that's illustrated right here in this line drawing. There are basically two areas of concern on Minnesota Point. There's the downdrift side to the southeast of the Duluth Canal. There is the downdrift side to the northwest of the Superior entry. Those are experiencing intense erosion. And then on the updrift sides, there is moderate to intense deposition. This is a persistent problem. It has existed since the structures were in place. The public is most aware of it during periods of high lake level, when basically coastal erosion is more widespread and noticeable. So those breakwaters act as barriers, and that's our problem. This is somewhat of an intractable situation, as you might imagine, because short of shutting down the harbor, which is not going to happen, we're going to be dealing with this indefinitely. I will just throw in one slide. This is an aerial view of the newly armored Lake Walk. You are looking to the southeast along Minnesota Point. You see the bridge there. This $25+ million project was actually done in an area of net deposition. So we can, again, debate the logic of that offline. This coastal erosion problem is real on Minnesota Point. It's not something to be trivialized. It's significant. So here is some very crude image work that I did a few years back. I took a 2017 Google Earth image and I overlaid it on a 1938 aerial photo. This is for the south entry. So this is the superior entry. The 2017 image is in color. The 38 image is in grayscale. And you can see the extent of erosion on the downdrift side and deposition on the updrift side. It's about 1 meter per year, so it is substantial. All right, this brings us to the issue of culpability. So in 2021, the then mayor of Duluth, Emily Larson, asked the Corps of Engineers to conduct what's known as a Section 111 study. So a Section 111 study is a study performed by the Corps of Engineers to address and assign culpability for any perturbations to the sediment dynamics that may be attributable to federal structures. It is designed as a one-shot deal. The Corps of Engineers will come in and design and construct some sort of mitigative strategy to help remedy the problem. The Corps of Engineers is largely responsible for all of this process. 2024, last year, was the 50-year anniversary of the first Section 111 study in Duluth, which was published in 1974. There was a second study done in 1998. And so this is the ongoing study today represents the third, and maybe it'll be the charm. What have we done in the meantime? In the meantime, to mitigate this problem, the Corps of Engineers has engaged in frequent large-scale beach nourishment, which involves, very importantly, taking dredge spoilings from the harbor, dredge spoils from the harbor, and dumping them out on the lake side of Minnesota Point, both at the north end, just south of the Duluth Piers in that zone of erosion, and on the south end of the point, just down drift of the superior entry. Those dredge spoils are finer grained than the native materials, the native sediments that comprise the point. They are loaded with all sorts of goodies, as you might imagine, and some of them sometimes contain, macrofossils, if you will, otherwise known as beer cans, etc. So that causes some consternation amongst the residents. So this beach nourishment has been ongoing for the last century. It happens in large events periodically, but then it also happens in smaller amounts as well. Just to highlight a couple of these, there was a big nourishment event in 1934. There was a particularly large nourishment event in 1963, and a pretty good sized one most recently in 2020 and 2021. So these are some aerial photos from the Corps of Engineers showing the beach nourishment process in place or in action. This is on the north end, just south of the Duluth Pier. Basically, there is a slurry of dredge spoils that are being pumped across Minnesota Avenue on Minnesota Point, deposited on the beach, and then reworked a little bit. There are some problems with that. Those dredge spoils are significantly finer grained than the native materials, and therefore they are highly mobile. In particular, they're mobile in wind. And so the residents on the north end of Minnesota Point are concerned with the large scale deposition of aeolian dunes in their backyards, et cetera. The same material is also very mobile in typical longshore transport. So you can see in these lower two pictures, on the left was an aerial photo taken right at the end of 2020 nourishment. By the next spring, much of that material had already been transported out of, down drift. And this is during a year where basically the storm season was pretty wimpy. So very mobile material. Just want to highlight a few points of these previous Section 111 studies. So the 1974 study, which was actually a very nice piece of work. I don't agree with the findings of it, but it was a well crafted study. Basically concluded that the federal structures, so again, the breakwaters, had some potential for causing problems on the north end, but that there was no actual damage that could be attributed to them. And the logic that the Corps used in 1974 was the following. It's summarized right here. Their logic was that if you look at the surveyed 1861 shoreline and compare it to the 1964 shoreline, you will find that the 1964 shoreline is actually lakeward of the 1861, and therefore there is no problem that can be attributed to the federal structures. So I will leave this slide up for a minute here. You can read it, and while we have this little pause, I'll just see if there are any questions. I mean, I've been bloviating here for 20 minutes or so. So does anybody have any questions? I have some more slides, but if there are any points you want to interject here, I'd be happy to entertain those.
I was just going to ask a process question that I probably should know, but I haven't been a sedimentologist for so long that I'm going to ask it anyway, is why does okay, I can understand why the sand gets dumped, you know, whatever, up gradient, if you will, of the breakwater.
Yep.
Is it more erosive past the breakwater just because the water's no longer carrying a sediment load and it's therefore more efficient at erosion?
Yep, it has, if you want to think of it, it has excess power because it's had its, it's a locomotive that is disconnected from the train load. So yes, you're absolutely right.
Okay.
So let's continue on here. 2001 findings of, so this is the second Section 111 study, were not really anything new. The Corps took responsibility for things on the south end, but the cost to mitigate the damages was above and beyond what the Corps can provide alone. So therefore the city is on the hook for the differential, and there was no money to accomplish that. It is no coincidence that the 3 previous Section 111 studies have occurred immediately after decadal scale high stands and lake level, and that's what we're in the process of studying this system for the 3rd time in response to the high stand from 2017 to 2019. All right, so where are we in December of 2025? We are waiting anxiously for the results of a complex hydrodynamic model that was put together by Barr Engineering. And that hydrodynamic model is used to come up with a culpability. So basically, the Corps is in charge of this study. The Corps contracted to Barr to do this modeling. And based on the modeling, the Corps will come back with a culpability percentage. They will say, we are responsible for X% of the impairment to Minnesota Point. And as part of this process, they literally want to be able to quantify how much sediment they are, for which they're responsible in cubic meters per year. And that's a fraught process. A little timeline of where we are in the whole flow chart of a Section 111 study. So this whole thing started in 2022. Here we are in 2026, and we have a long way left to go. So what is the city's position? It's our position that the Corps is 100% culpable for basically perturbing the system with respect to sediment supply. In other words, it's our position that the breakwaters trap all of the sediment that was originally supplying Minnesota Point from the North Shore and the South Shore. This is important because that would then suggest that the Corps' culpability number is 100%, and that opens more doors financially for mitigative strategies, although we'll talk about that in a second. This is a contentious issue, as you might imagine. We've been going back and forth with the Corps a bit about the way that accounting is, how do we account for sediment that is being trapped or stored on Minnesota Point by the long-term lake level rise, the subsidence, if you will, that is the whole, reason for the point being there in the first place. This is where sediment goes to die, if you will, in the Western Arm Lake Superior. In the Corps' algorithm, those natural losses are discounted. So we, in effect, the city of Duluth would be on the hook for the percentage of the sediment supply that would have been trapped by subsidence. And our position is that number is 100% of the sediment that would have been trapped. So therefore, we would end up actually owing the Corps money. Well, kind of. So the Corps nourishes, as we've discussed, and that nourishment is actually quite substantial when you think about the long-term, what we know about the long-term sediment budget. In other words, the Corps is not, with dredge spoils, is not completely replacing what would have been supplied to the system naturally, but they are replacing a significant zero order, fraction of it. So that complicates things a bit because the material they're supplying for nourishment is very different than the native material, and there are implications associated with that, which again we can discuss afterwards. So what are the possible strategies to mitigate this scenario? This is a diagram that's been presented many times by the Corps of Engineers. It gives you some scenarios, some strategies to address the problem if it turns out that the Corps assumes a sufficient level of culpability that the city can afford to go forward with the process. Of these, the most likely is to continue what we've been doing for the last century, which is beach nourishment. But that is a very unfavorable solution in the eyes of the local residents because of the mobility issues associated with the fine-grained sediments. I say this kind of tongue-in-cheek, but also kind of seriously. In my mind, the long-term solution is to locate as best as possible the position along Minnesota Point where, historically at least, the North Shore sediment supply and the South Shore sediment supply were basically exhausted by deposition. Call that the zero flux node. If you can locate this position and install a single pair of breakwaters, you would mitigate a lot of the problem, as long as you, of course, removed the existing Duluth and Superior entries. That'll never happen for all the obvious reasons, but it's certainly worth entertaining. Okay, last point I want to make here, and then I'll be done. If you recall, early on in the talk, I mentioned how the idea of increased magnitude and frequency of coastal storms is often suggested as a possible causal mechanism of the increased or apparently increased erosion and associated problems that Duluth is experiencing. Once again, if you use AI, just type in something to Google, you'll get the following. Climate change is a major driver of coastal erosion in Duluth through increased storm frequency and intensity. Likewise, there are numerous examples of this. These are just two, but here's a March 2024 article. However, as climate change has resulted in more frequent and severe storms, the lake walk is blah, blah, blah. So there is a pervasive idea that there are more frequent and more intense coastal storms affecting the far western arm of Lake Superior and the Duluth area. So I recently had a graduate student set out to check that. This seems to me to be something that we can, a hypothesis we can test. So Maddie Ryan, last year defended her master's degree on this. And what Maddie did is grab just shy of 80, so let's call it a century of high resolution meteorological observations from the Duluth airport, and she processed those data for storm statistics. She focused in particular on one metric, and that is pressure falls associated with cyclones approaching and impacting the Duluth area. So this is a very robust, frequently used indicator meteorologically of of storms. And what Maddie found is that there is no signal. There is no statistically significant signal. So if we actually look at her results, they are plotted right here. This is a busy slide, so let's spend the last minute on this. What you have here are time series. So the horizontal axis in all of these figures is the year, so time. And then the bar chart is simply the count every year of the number of cyclones that are larger than a certain threshold. So we bend, if you will, the storms based on their intensity. In the figure you're looking at here, the upper panel represents the strongest storms. So these are very intense extratropical cyclones affecting the Duluth area. The next column or next row down, B, is still geomorphically significant storms, but not as intense. The third row is storms that, you know, it wouldn't be a pleasant day, but geomorphically, system's not really on, if you will. And then the final two panels there, delta and echo, represent just lumping things together to look at sort of whole statistics. Long story short, at this sort of very, I don't want to say it's a cursory level, but at this relatively simple level of analysis, Maddie found basically no statistically significant change in storm frequency or magnitude. So it would seem that there are, you know, there must be alternative explanations for the coastal erosion problem in Duluth. I think for Minnesota Point, the answer is pretty obvious. But for areas outside of Minnesota Point, so in other words, outside of the effects of the federal structures, so along the North Shore, for example, or the South Shore, the apparent increase in the significance of coastal erosion is, I think, much more easily explained by simply two things. One, increased population, increased home ownership adjacent to the coastline. And two, the simple reality that when Duluth was founded as a city, and people, you know, platted properties and built homes for the first time, they did so with an intuition as to how far back they should be from the coastline. And in simple terms, that time scales up. You know, 120 years has been enough time for bluff retreat to bring the problem closer to home, so to speak. So I think, remarkably, I finished right on time, which I should go buy some lottery tickets.